Okay, so this packet is about transformations. So these are your basic transformation rules for rotations, reflections, and dilations. And we're going to just go through some examples for your packet. So first we have some vocab here. So translations are just moving a figure in the same direction and the same distance. So we're just taking the figure and moving it over, and we'll have an example of that down here. Vector or component form is when it is written like this, and so it's like our x, y, and so it moves the x value +2 and moves the y value -3. Alright, the image is what we call the new figure after that translation. Pre-image is the original figure. Okay, so here we're going to go ahead and label the points of the pre-image and then find what it is when we take it through this transformation. And so my A point is, this is my x-axis, this is y. And so that is +2 and then -3 for my y. B is that same +2 line, and this time it is -8. And so all I'm doing, if it gives me a translation in this format, is I'm taking my x and subtracting 6 to get -4. I'm taking my y and adding 8 to get +5. And then I graph the point for my A prime, and so image will always have this apostrophe to let you know that is your new image. And so I go ahead and graph -4 and +1, 2, 3, 4, 5, and that is my new A prime. I could also take this and just count. So I could have counted 1, 2, 3, 4, 5, 6, and then up 8, 1, 2, 3, 4, 5, 6, 7, 8, and then I graph it from there. And so with B, rather than just doing the math first, I'm going to just count. So I'm going to take my B point and count 1, 2, 3, 4, 5, 6 backwards, 1, 2, 3, 4, 5, 6, 7, 8 up, and that will be my B prime. And then I will label that is -4 and 0. And then I check the math. So yes, 2 minus 6 is -4, -8 plus 8 is 0. Alright, so now you're going to do the rest of these as part of your practice. See if you can move the rest of the figures and then connect them to make your transformation. Alright, these ones it already has graphed for us. We're just describing the transformation in that vector form. So that means I'm going to write all of these in vector form of how has x changed, how has y changed. And so from A to B, I just have to make sure whichever corner I start with here, I find the same corner for B. And so if I start here, so I'm going to mark from here, just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was 10, and I'm moving forward, so it's +10. And then 1, 2, 3, 4, 5 is coming down 5. And if I wanted to check another point, I could check. Same thing if I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 5. So that's the same 10, negative 5 to match up with this point. So I checked that it matches both corners. So again, you're going to do your same thing for these two, is match up corner to corner, corner to corner, and see what your rule is. Alright, so this one, we're going to start out by plotting our pre-image, so our points of -2, -2, which is A, -2, +1, which is B, C is 1 and 1, D is 1, -2, and then I connect them all. Okay, so I did those first two, and then you do this part and see what type of figure you make. So that is our translations, and so a lot of your rotation project will probably be translations because we're just moving figures around. Next one is rotations. So rotation is just turning a figure around a fixed point. Center of rotation is the fixed point. Angle of rotation is how much you rotate. And so for the purpose of this unit, we're doing 90 degrees, 180, or 270 degrees. And then rotational symmetry is when you rotate something and it's symmetrical. So that is our rotational symmetry. Okay, so here's like our rotating cheat sheet. Tells you the basic things. If we have a point starting here where A and B are positive, and we go 90 degrees counterclockwise, we're going to flip the order, and so it will be negative whatever the B number is, and then positive A. If we go 180 degrees, it'll be the same A and B, they're just both negative because now we're in this quadrant. If we go 270 degrees, you'll switch the order and make A negative. So that's one thing you can do to choose. If you're starting somewhere else, you again just look at, hey, what order is it going to be? Our numbers will always be the same, just our positive, negative, and order changes as we rotate. And so first thing we're going to do is just, hey, can we recognize rotations? So when we're going this way, we're just going clockwise. This way is counterclockwise. And we can abbreviate it with 2 C's so we don't have to write it all out. If we're turning things 90 degrees, that's just a quarter turn. 180 degrees is a half turn. 270 is 3/4 of a turn, which is the same as 1/4 in opposite direction. And then 360 degrees is 1 full turn. And so each of these we're going to look at, hey, what is it clockwise, what is it counterclockwise? So A, turning it this way, if we're going clockwise, that's just our 90 degrees clockwise. If we're going backwards and going around, we'd be going 1, 2, 3 counterclockwise. So that's our 270 counterclockwise. And so then you're going to do the next two and check with your teacher on your answers for those. Okay, so when I'm doing this, I'm going to start by labeling my points. So A, B, C. A is -4, 2. B is -7, 7. And C is -3, 9. So I have my original points, and then I'm going to make my 3 new rotations counterclockwise. And so I start, my next set of points I'm going to find are going to be A prime, B prime, and C prime when I rotate 90 degrees counterclockwise. And so I can either look at my rotations cheat sheet and figure out the points like that and graph it, or a lot of people like simply turning the paper. So I turn it 90 degrees counterclockwise, which means I turn it this way. And I label as if my paper had not been turned. So now if I'm finding A, well, A is -2 and -4. B now is -7 and -7. And C is -9 and -3. So I write those numbers in here. And -9, -3. And then now that I've turned my paper the right side up, I plot them on this graph. So -2, -4 is my A prime. -7, -7 is my B prime. -9, -3 is my C prime. And I connect them. And I see that this now looks the same way as this looked when I did it. If I compare it to my cheat sheet, I can see I did exactly what it said. I went from here, I switched the order of the two numbers, so -4, 2, switched the order, and they both became negative. So -2, -4, -7, -7, -9, and 3. And so I was just using this if I'm rotating from the 180 degree to the 90 degrees counterclockwise is the difference between those. Some people really like this cheat sheet. Some people find it confusing. And so now your part to do is the 180 degrees. So that would be your A double prime, B double prime, C double prime. And then do your 270 degrees, which will be our A triple prime, B triple prime, C triple prime. And you will both find the coordinates and graph them on here. And your final answer should look similar to this, where it looks like it's just a fan wheel turning all the way around the center. So that is it for our rotations. Next is our reflections and lines of symmetry. And so reflections are just transformations that reflect across a line. And so it uses a line like a mirror. That line of reflection is the mirror line. Okay, so if we label these points, so A is -3 and 4, B is our +4 and 2, we go ahead and connect them into a triangle. And if I'm reflecting across the x-axis, so A right now is 3 this direction, to reflect it straight across the x-axis, I'm just going to come 3 in the opposite direction. That will be my A prime. And so that is +3 and still 4. If I do B, it becomes, instead of +4, I'm just going back -4. And so I'm just going the same direction across the axis. Alright, you do C. And then C, can you see the pattern? What is one of X and Y? So X stays the same, Y, what's changing to it? See if you can identify that pattern. Okay, so that was reflecting across the y-axis when we went the same direction here. Now we're reflecting across the x-axis. So that is this line here. So I take my x, which is up 3, and I just come the same distance down 3 from there. And that becomes my x prime. And then I label, so this was -2, 3. I'm still at -2, but this time I'm at -3. And so then you're going to do the same thing for these next 2 points, connect them into triangles, and see what it looks like when you flip it over this x-axis, and see if you can tell what the pattern is. Our last reflection is across this diagonal line, y equals x. And so because it's a diagonal line, I have to count diagonally. And so if I'm starting with R, I'm going to count straight through the corners of these of 1, 2, 3, 4, 5. So it's 5 diagonally this direction, and so I do 5 diagonally the other direction. 1, 2, 3, 4, 5, and that is my R prime. And if I look at those coordinates, so R was -4, 6, and then if I count this time it is 6, -4. And so there's a really easy pattern there to follow if the counting diagonally confuses you. S is an easy one to see because S counts 1 1/2 this direction, so I'm counting the half and another 1 here, and that becomes my S prime. And so it went from -1, 2 to 2, -1. And so you do the last one. And what do you see as a pattern? And then here's your cheat sheet, same as on the front of the page, is just saying, hey, these are the rules. If you're a rule person, you can use these to help you making your reflections. So the next part is just lines of symmetry. If we look back at this page, we can see on this one, our line of symmetry was that y-axis. Everything was exactly the same on either side of the y-axis. On example 2, it was that x-axis. In example 3, it is our y equals x line. So line of symmetry is just, hey, what are these things reflecting over when we've reflected them? When we have other figures, we still find these lines of symmetry. And we're just looking at, hey, where could we draw a line that would make the two sides an exact mirror image of each other? Where could we fold it in half? And so here, I can do it exactly halfway through, and I have one line of symmetry. On the other ones, you're going to do all the other ones and see, compare it with the person beside you, see, do you get the same number of lines of symmetry in each of these? Okay, so when we're talking about dilations, we're just talking about getting bigger or smaller. And we do that around a fixed point, and scale factor is what we're multiplying the pre-image by. So here we're finding the scale factor and say, hey, are we reducing it or enlarging it? Are we getting bigger or smaller? And so you just have to remember that P prime is that new image. So as we go from P to P prime, is this figure going to get larger or smaller? So hopefully you recognize this as a reduction, because this little part of it is smaller than the whole thing. And if we look at the numbers here, it would be 2/4, which equals 1/2. So this is a reduction with a scale factor of 1/2. Alright, and then you do these next two in your packet. Okay, these are our basic rules for how to produce dilations. You'll be doing this on your animation project. And so you count your rise and run, similar to slope, from whatever center they give you to the point. Multiply those numbers by the scale factor, and then plot your new image with your new rise and run. And so this says use slope to produce a dilation with a scale factor of 2. Okay, so that's what we're going to multiply everything by. And then B is the center. So I'm just going to count to get from B to A. My rise from B to A is coming down 2 and coming backwards 5. And so I multiply both of those by my scale factor to find my new point is going to be coming down 4 and backwards 10. And so from B, I come down 4 and backwards 10. And that is my A prime. If I've done it correctly, it will be straight in order there. Some people like to just take whatever your pattern is and count it out twice. So I could have counted down 2, back 5, down 2, back 5, and found my point that way. Now I just have to label my -7 and +1. Alright, and you're going to do C. So to get from B to C, what is your rise? What is your run? Multiply it times 2 and find out your new answer. Okay, this is almost exactly the same, except now we have a small scale factor. So our scale factor is 1/2 here, and we're using X as our center. And so I'm still going to start out to get from X to Y. I come down 1, 2, 3, 4, 5, 6, and backwards 1, 2, 3, 4. So down 6, backwards 4. And now I'm multiplying those both times 1/2. And so half of 6 is 3, half of 4 is 2, And so I come back, and this time I come down 2, down 3, back 2, and if I've done it correctly, my x line is going to show up exactly halfway through x and y. And again, I could have just counted those and then gone back, divided in 2, counted half. And that gives me a point of, I labeled that wrong, sorry. My new point is y. So that gives me a point of 4 and 3. Alright, so then the last one is, it looks just a little different if we use our center of 0. So here the origin is our center. Okay, so here I am taking from the origin, from 0, 0, I'm counting my rise and run to get to D, because that's my first point. So I count up 3 and over 6. I multiply those both by 1/3, or divide by 3, and so that gives me 1 and 3 is what I am going to count out for my D prime. So now I count up 1 and 1, 2, 3, and that is my D prime. So when our center is our origin, we aren't doing a point on the line like before, but it will still look in between those two. That's wrong. 6 divided by 3 is only 2. And so it'll be 1 and 2 will be my rise and my run. So it needs to be 1 and over 2 is my D prime. And so that gives me coordinates of 2 and 1. Alright, you do A and B. See what you come up with. You should end up with a small triangle drawn in the middle there. It looks like the same as the big one. Okay, so this is our level 4, which means if you're not in an advanced class, it is optional whether you do this. It says to graph the polygon and its image after dilation centered at C. So this time the center is not the origin, it is not a point on it, it is a separate point here. So this is already graphed for you, and we're just the same thing, we're still counting. So to get from C to L, I'm going backwards 1, 2, 3. I have 0 rise. And then my run is -3. And so I don't care about the rise, I'm just going to take that -3, multiply it times the scale factor of 2 to get, I need -6 run for my new point. So I start at C again, and I come backwards 1, 2, 3, 4, 5, 6, and this is my new point for L. That's my L prime. I do the same thing for K. K is still 0 rise. And then my run for K is our 1, 2, 3, 4, 5. I multiply it times 2 to get -10. And so from C, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's my K prime. You can already see that looks correct. This length looks twice as long as that. So now you do J. You figure out J prime, plot it, and find your coordinates. Alright, the last page, still level 4, and we have again just more practice we are doing with these. So this is another one where our center is at 0, 0, and I'm going to show you a shortcut. When we did our center of 0, 0 on the last page, we counted out our rise and run from the center. If we had labeled that coordinate would have been labeled 6, 3, which is the same numbers that we got here for rise and run. So rather than going through this whole process, we can label that original coordinate and then multiply it by the scale factor. If we had taken our point of 6, 3 and divided each of those numbers by 3, that would give us the same 2 and 1. So on here, our shortcut is we can take that original coordinate of -10, 0, multiply it times my scale factor, which is 1/5, to get my P prime is -2, 0. And so then the rest of this is for you to do. See if you can line those points up, multiply by scale factor, and plot it. Our original P would have been here. P prime is all the way in here. Alright, so you do the rest. Alright, and then these last two are without plotting it. It's just if we have that scale factor, can you go ahead and multiply them out and find your new coordinates? So again, this is one for you to do. Check your answers with your teacher when you're finished.